Okay, to begin with, today we are going to check on the binary operations which are available under NumPy. So let us quickly import NumPy. There are some functions like bin, then np dot bitwise operators like bitwise and bitwise or. Okay, we also have function like invert. Okay, let us take some small examples, and then we'll also see left shift and right shift for your bitwise operators as well. Okay, so I'll just print a statement here, print say binary equivalent balance of, let's say 14 and 17. Okay. Now all those who have done C programming might be knowing, okay, usually whenever the number or any programming language, whenever the numbers are stored in the memory, they are actually converted into bits first, and then it is stored. Okay, and the bitwise and or, there is a truth table which says that, especially in case of and, one bit, 1 and 1 is equal to 1, and any other combination where 0 and 1 is 0, 0 and 0 is 0. Okay, so if I'm trying to perform a bitwise AND operation on the two numbers, actually what happens, the bits of each, you can say, number is compared, and then depending on this truth table which I told you, 1 and 1 will always be 1, and any other combination, even 0 and 0 will be 0. Now in case of OR, the bitwise OR, if any one of the bit is 1, the result will be 1, else it will be 0. So only 0 or 0 will be 0, whereas all the other combinations, 1 or 1 is 1, 0 or 1 is 1, 1 or 0 is also 1. Okay, so I'll just show you the binary equivalent of these two numbers. Now to get the numbers, first of all, let us assign two variables, so A and B. I'll assign 13 and 17 to it, and let us print the binary equivalent. So I can write bin into bracket A to get the binary form of 13 and 17 as well. Let us execute this, and here you can see the binary equivalent for 13 is 1101. That is the binary equivalent. And for 17, it is 10001. That is the value for 17, the binary equivalent for 17. Okay. If you want, you can also do it manually. How you do it, you divide the number by 2, and the remainder you write it on the right hand side. And to get the binary equivalent, you write the binary number from bottom to top. Okay, the remainders. So you'll get this 1101 for 13 and 10001 for 17. Okay, let us write the bitwise operator. Let us use the bitwise AND on these two numbers and check the resultant value. So to perform that, I write let us say /n on a new line character, bitwise AND of 13 and 17. Okay, and I can print here, print. Now the function which is available is under the NumPy object np, so I can use np dot bitwise. Now you can see this bitwise AND available here. So bitwise underscore AND. Okay, it takes two parameters, the two values. So I'll pass A comma B. Okay, when you run this, I get the bitwise answer as 1. Okay, that is my result. Now this is in not in a binary form. The answer is not in binary form, but is in you can say decimal form. Okay, base 10. Similarly, if I want to find the result of bitwise OR, okay, I can print it like this. I can say print the bracket /n bitwise or 13 and 17, and again print np dot bitwise or okay, and you pass the two values. Now that is the answer for your bitwise or 29 is the answer. Okay, so these two functions will help me get the bitwise, perform the operation bitwise and or. There's another function which is your invert function. Okay, so if I have to find the invert of the number 13, okay, you can say not. What happens is it converts your zeros into ones and ones into zeros. And one more thing you'll notice that the last other, you can say the last bit, if let us say it is, I'm using int 8. Okay, so there'll be 8 bits. Okay, the last bit is always stored for your sign, that is your positive or negative sign. Right? So if I have a positive number, if I have a number like a 13, if I want to convert that in or invert it using the function invert, okay, I might end up with a negative value. So let us try to invert this same number 13, and I'll give a print statement /n. So invert of 13. Now in this case, I'll try to make use of the D type. I'll change the data type to uint8. Okay, so let us write it there where D type is uint8. Okay, and one more thing I'll do is I'll make use of an array while displaying it. So the parameter which I'll pass for invert, let us do it here, n into bracket np dot invert, okay, round brackets np dot array, and in this array I'll just keep that value 13. Okay, 13, and I'll put a comma and mention the D type. The D type is equal to np dot int a. This one. Okay, and let us see what the output comes like. What's happened is not subscriptable. Okay, so here we have, okay, let us try doing it directly. So if I give E, and let us check whether it is able to do it. Okay, I have removed the D type. So here you can see that number has, the 13 has been now changed to -14. And as I told you, the sign is also inverted. So if the sign is represented by 0 and it gets converted to 1, okay, it becomes negative. Or if it is 1, it becomes 0, whatever the sign might be kept, stored in the air. Okay. Now, why a D type is not working here, we need to check it out later. Clear, but invert is again a bitwise operation, and it converts your zeros into ones and ones into zeros, and your positive value will change to negative. Let us try one more thing. Change this to a negative value and check whether we get something else. Fine. Here you can see now previously I was getting a -14. Now I'm getting a positive number and I'm getting 12 is the answer. Clear? So you can try all such experiments with the numbers. You can also do it manually and check it out whether it's really coming as per the required value, desired results. Okay. Now, there is another way of displaying your binary numbers of the given number like 13 and 17. What I can, there's something in chat. Okay, Advaith has a question. So where is it used? Now, especially when we are doing mathematics calculations, or you can say when we want to modify the data. Let us say encryption and decryption. For a simple example, suppose I want to encrypt my file. Okay, so all your passwords are encrypted. So I can have come up with some algorithm where I might handle the bits and not directly convert a character into something else. Okay. So there can be some logic where I can make use of the bits, especially the left shift, right shift, the invert, or the ands and all. We can have a combination, and then to decrypt it, once we encrypt using the bitwise operators, I can decrypt it using the reverse of it, so that I get the actual contents. Okay, so there are applications where we can make use of all your bitwise operators. Clear? So this is just one simple example which I took. Fine, let us go ahead, and especially when we are handling lots of numbers, numerical values, you'll find that especially in case of research and scientific research, you'll find lots of manipulation happening with numbers, especially with the bits. Okay, and one of the most important one is, I think, encryption and decryption. You can say encode, decode, and all. Even that, there are some functions which are available for encoding and decoding as well. Okay, fine. Let's go ahead and see some other function. There's another function called binary underscore representative. So REPR is one function which helps me present my number in a binary form. The advantage of this function is that I can mention the width, how many characters width I want, while displaying the equivalent binary form. Fine. So let us take a printf statement here, or print statement, and I'll just write here binary equivalent or representation in, say, 8 bits, 8 bits. So let us say 13 itself. Now, suppose if I want to represent 13 in 8-bit forms. Okay, so previously what was happening, whatever the answer was, the same answer got displayed, and for 13 I had got 1101. Okay, and because initially it was like a 0 1101. Okay, so and I got -0 or 0B and so on. If I don't want that, I want to represent in a simple form, I can use print np dot. See, there's a function called binary REPR, that is this one. Okay, and the number is, say, a comma. Here I have to specify the width. So width equal to, and I can mention it as 8. Fine. So now when I run this, here you can see this last one. There are 8 bits now, and it has been represented, your 13 has been represented in the form of 8 bits. Clear? Now let us say if I have a very big number, let us take one more number instead of 13. Take a number which is, say, 200 something. Let us take print. I'll use slash n. Say binary issue of, say, 242. Let's try this one. So print into bracket np dot binary underscore rep into bracket the number. So I'll give the number directly now because I don't have a variable here. So I can pass the constant value as well. So 242, and here if I mention the width, width is equal to 8. Okay, so you can see this number, right? So 11110010. Clear? What is the maximum number depends on the width also. So how many numbers? If I give a very huge number, whether it will be able to store it in the width 8 is not possible. Okay, so depending on the number also, you can change your width as well. Fine. So this is another way of representing your binary equivalent of a given number. Now there are two more functions, like the left shift and the right shift. What does the left shift does is, it will shift my bit to the left hand side and add a 0 to the right hand side. Okay, so it's actually changing the position of all my bits by adding another 0 either on the right hand side, depending on whether I'm using left shift or right shift. It will decide the position, whether it will go on the right hand side or it will move on the left hand side. Okay, so if I have a function called left shift, let us try to see what happens if suppose there's a number and I want to shift this number by 1 position, 2 position. I have to mention the number of positions by which I want the number to be shifted, or the binary digits or bits to be shifted. Okay, so let us use the first function, the left shift. Okay, let us take a number, left shift, say 10 by 2 positions. First of all, we'll try to represent the binary of 10 first. So we'll write binary of 10. And we'll display the binary form of 10 first. Yeah, print it here. In this case, I'll use np dot. I'll use binary underscore, okay? Okay, and the number was 10. The width equal to 8. Okay. And then I'll perform the shift by using the function np dot left underscore shift. Okay, so we'll see both the difference, print np dot left underscore shift. Okay, the number is 10 and I want to shift by how many positions? 2 positions. So I give 2 here. And one more thing I can do is, let us first see the answer, and then we'll also represent after shifting by 2 position. I'll represent that again, the number by in binary form, and check how it is moved. Okay, now this is the binary form of 10. Okay, it is 0 0 0 4 zeros 1 0 1 0. Now what I'll try to do is, let us create one variable called c equal to, and I'll delete this print, and after shifting it, I'll store it in this particular number c. Okay. And here I'm going to print the binary equivalent of c. Okay, so np dot binary representative REPR into bracket c comma with equal to 8. Now I can compare the two binary forms, how really it is shifting the numbers or not. So here you can see, now you can see this, the two zeros have been added on the left hand side, and you can see this has been moved by 2 positions. Okay, so one has moved to 2 positions on the left hand side. Clear? Similarly, if I want, I can also perform right shift. Now remember, the left shift is increasing the number. So the number which I got in C was 40 something. Right? If I now do the right shift, okay, let us take a number, say, I'll say print into bracket. Or let us take D. I'll take a number, variable D equal to np dot right shift. So right underscore shift into bracket. Let us move C again by 2 positions. Okay, so that it comes back to 10. Okay, so if I want to print this number, it should be 10 again. And I can print this, print np dot binary into round bracket. The number this time it will be D, and comma, let us give the width as equal to 8. Okay, and when I run this now you can see this. I've shifted the same number again to the right hand side. It's come back to the original number. Okay, so whenever you want to perform any shifting or movement of the bits of a number, okay, you can either make use of the left shift or the right shift. Clear? So these are some binary operators or operations which can happen in your NumPy. Now I'll create a new file. Let us first of all, let me copy this. We'll create a new file, and the next topic which we'll take, we'll see some string functions which are available under NumPy. Okay. The first function, I'll quickly go through all the functions. These are very simple functions. Actually, at the beginning, I think we did not take any string functions in Python. Okay, so that's one topic which is still remaining. I could not take it. Now, the first function which we'll do is concatenation. If I want to add 2 strings together, okay, so I won't type anything else. I'll directly type the functions and I'll show you how it looks like. Now, while giving this function, it is available under np.char. Okay, so char is again a module which is available under the package np. Okay, and the function is under char. So we have a function called add. Okay, which will you can say perform string concatenation. Here you can see it's string concatenation for 2 arrays. Okay, so I can give add into round brackets. I can pass 2 string arrays. So let me put it in square bracket. Let us say hello is my first string, and comma. I can give some name here. Say Bob. Okay, so hello Bob. I'm combining this two, and because I'm going to combine this string, I'll give a space here so that it looks good. Let us run this. Here you can see now I get hello Bob as a single string now. Okay, so add is the first function which helps me concatenating 2 strings. You can have multiple strings as well. Let us say instead of having only single string in the array, if I say print np.char add round brackets, my first array, if in this having say hello, and it also has another string here, comma, say hi. Okay, this the first array. The second array will come after this comma. I can give you say Bob. So again, I can give a space here, put a comma, and here I give say John. Okay, I can combine this as well. So what will happen? Hello will get concatenated with Bob. So I'll get hello Bob, and then I'll get hi John. So here you can see this. There are 2 strings now: hello Bob and hi John. Okay. So add is the first function. Next function, if you remember in Python also, we had used the multiplication sign. Okay. So if I multiply any string by say 2, 3, what happens? That that string gets repeated again and again, that many times. Okay. Now, similarly, we have a function called multiply. So I can write print into bracket again np.char.multiply. Okay, so here's the function, and whatever I want to, the first one will be the string. So if I want to say, let us say Veer, okay, and put a comma after this. So this character or the string, I want to, let us say, multiply 3 times. Okay, so when I run this, yeah, you can see wheel is coming 3 times. Okay. Yeah, let us give some other space. Say wiki. So wiki is coming 3 times. So similar to your multiplication, the asterisk sign, we also have a function called multiply. Now there's another function called center, which will return an array of the required width, and so that the input string is centered and it is padded on the right and the left hand side with some fill character. So it is not going to just center as per the width of your line or something, but it is going to add some fill characters at the left and the right hand side. The function goes like this: it's print into bracket np.char dot center. Okay. Now it takes 3 parameters here. The first is your string which I want. So let us say I want to put hello. Okay, I want hello. Second is your width. How many characters? So let us say is somewhere around say 20. And the third one is your fill character. I want to fill it with some particular character. So I say fill char equal to space. I could have given space also, but to just show whether that character appears or not, we'll give an asterisk sign here. So where's the asterisk sign? Yeah. Okay. And the best way is to give a space. So here you can see we have got some, asterisk signs, and it has been centered. And if I just remove this and keep a space here you can see it is. So we do not know whether it is centered or not, depending on the number of characters. So the fill character basically should be space and not something else, depending on your requirement again. So for this example, I'll keep an asterisk. The next character function is capitalize. It returns a copy of the string with the first character as a capitalized one or in uppercase. Okay, so I'll quickly type the function. I'll say print np char dot capitalize, okay, and pass the character. So if I say hello world, what is going to happen? The first character will get in uppercase. So H will be in uppercase now. So when I run this, you can see this H has been converted to uppercase. Okay, but what if I want the first character of each word to be in uppercase? For that, we have another function called title. Okay, it returns the title case. You might have used this in Word also. In Word also, we have a case proper case. Okay, in proper case means it converts the first character of each word into uppercase. So let us use that. So I can give print np dot char dot title. Here it is. Into round brackets, we can mention. Let us say I'll give a bigger string this time. Say hello, and I say how are you? Okay, and when I run this now, here you can see now each character, the first character, has been converted to uppercase. Clear? So, like capitalize converts only the first character, title will convert the first character of each word. Okay. Then we have functions like lower and upper, which is a very casual function. The name itself indicates it will convert all the characters into lowercase. And we have another function called upper, which will convert all my characters, all elements in my array into uppercase. Okay, so quickly we'll take that two functions. So print np dot char dot lower, okay, into the round bracket. I can pass the array here, so I can give square bracket. Let us write give some 2 words. So I'll give hello, and I can give a comma here and let's say the world. Now, because it is already lowercase, let us complete this into hello like this. And in this, I'll put only one character as capital. Okay, I hope it's fine. So here you can see all my characters. If it is lowercase, there's no change. And for uppercase, it is converting into lowercase. Similarly, we have that function np.char.upper into bracket. Now, in this case, let me pass hello. And I'll pass only one. Let us run this. Okay, here you can see now it is converted into uppercase. Okay, so this two functions which is commonly available in all your string functions. Okay, now there are some functions which can be used to split your characters. Okay, so there's a function called split which returns a list of words in the input string. So let us use that and print it. So I can get print into bracket np.char split into round brackets. I can give a big say hello. How are you? Okay, and complete this. Let us run it. Okay. Now you can see this. This string has been converted into an array of say characters, and it has converted. You can see this is one word, second, third, and fourth, and so on. Right. Now there's one more option. If I want, I can also specify the separation character. If suppose I want to split it, but I want to split it at a particular character. For example, let us say if I have some string where I have separated each word with say a comma or a colon or something like that. Let us say np.char.split. Okay. Now in this, let us use some city names. So I have Mumbai, say Pune, and say Jaipur. Okay, I have three names. Now this has been it is separated by a comma. If I want to specify this, I can give comma, and I can indicate the value, the separator key equal to. So comma is my separator, and now when I run this, okay, what's happened? I cannot interpret as an integer. Split. Now Mumbai is given Jaipur. Line number NP. Okay, I hope this is okay. Fine. Sorry, I put almost everywhere. Single quotes. Okay. This is my whole string. Now it should run it. Right. Okay, so here you can see this now. It's been converted. And there's a space here. I need a space here so that Jaipur also comes as a second, third one. Right. Fine. Now we can also separate the words depending on the number of lines. Let us say we have a big, you can say, file where I want to access all the values and then display each line on a separate line or while displaying it, and not continuously. Now, as you know, there are some characters which is used for new line character. That is your /n. It's your new line character. It is also, we can call it as a line boundary. Okay. So there's a function called split lines, which helps me, getting one line at a time. So we'll take an example. There's a option like even /n. We also have a combination of /r and /n. Your /r is nothing but your carriage return. Okay, /r. So if I want to give a new line character, either I can give /n or I can also give /r or I can give a combination of /r and /n. All three, considered to be a new line character. So to give you an example, I'll use a print function. Okay, and in the line which I'm passing, I'll try to put a /n there and /r as well. So np.char dot split lines. So this is my function, split lines. It will take the string as my parameter. So in single quotes, I can write say hello, and let us give /n here. /n is your new line character. So how are you? Okay, and here I'll give /r, and I'll write I am fine. Okay, I'm fine. And let us run this one. Fine. Now you can see this now the whole string. So hello has been extracted as the first line. Then comes my second line as how are you, and then the third line, I am fine. Okay. So please remember your /n/r or combination of /r/n together also indicates it's a new line or it is a end of the line. Okay, so you can split lines as well by using split lines. Okay. Now there's another function which is called a strip function. If I want to eliminate or remove a particular element from a string, okay, either from the leading characters from the beginning or from the end or from in between, I can make use of this function. Let us take an example. So I can write here print. We have only 1 minute left. So if I'm not able to complete this, we need not join. We'll continue in the next session. So we have this strip into bracket. I can mention, sorry, this single quote is not there.